Gradually, as these second row of purlins go in, it gives the structure a lot more rigidity. So they just add in the second row of purlins, and once that wall is completed, they'll start on another wall. These purlins are exactly the same size on 3 sides. The only one special wall we've got is the wall that has the door on it. So it's very easy to identify where these go. They all on 3 sides are the same size. So the one wall that's the gable end, which is where the door is, the purlins are marked as special purlins, and that's easy to separate. So the red that we have here represents the foundation. This needs to be 2 foot wide. In this case, this unit here is 9 by 9. If it was a bigger, it may need to be wider, but in this case it's 2 foot wide, 2 foot deep. You pour an initial 6-inch base foundation, and that is what these will then sit on. So before this frame gets put in, you pour in 6 inches of concrete and letting it set, and then we come in and erect this frame. Once this is bolted into the base foundation and the frame is completed, you would then come back and then pour 16 inches or 18 inches, sorry, of concrete to bring it back up to 2 foot. This is a T-bolt, and these T-bolts are parallelogram. They're designed to go into the T-slot. This is the patented aluminum 4-sided cord that we use for houses. It's basically designed to fit this T-bolt. The T-bolt goes into the channel, turns 90 degrees and locks. So it allows you to put these T-bolts anywhere on all 4 sides, so we can connect any which way we want to. So using the T-bolts, they've secured 2 rows of the roof purlins. You also see the use of this bolt. This is a grade 8 5-inch, half-inch bolt, and they use this in certain locations with purlins, but not in very many places. These are used mainly for the mini cord, the patented beam connections that you see over there from the verticals coming up, and the cross members. So every vertical cord of the RDS patented 4-sided cord is going to be bolted with the half-inch, 5-inch bolt through the top cords so that they're properly clamped. Once the steel goes on, we're going to unscrew this nut, put the steel on top, and then re-tighten the nut to secure the steel. So everything is through bolted through this cord system, and it's extremely strong. You've got a combination of coated steel going onto the aluminum cord, and it's properly secured using these grade 8 bolts, which are extremely strong. And then that combined with the T-bolt strength that you've got 4 in each purlin, it's immensely strong. You can also see from this side view that the vertical beams, like we showed earlier, are anchored vertically, and they're also bolted through horizontally that top cord. Everything is locked together at this point. So here for the center beam, we've got these H brackets. The bolts are left out of them here and here, and the reason for that is the steel plates on the top are going to be through bolted all the way through the cord and this bracket. Here is the rebar setup. We've got rebar down here at the base plate, coming through the base plate, and then it's joined to 2 verticals either side of the leg. And this would be the typical rebar setup all the way around the perimeter before we pour the foundation. So at the minute, if we come to this corner, it shows the base plate bolted down, and we showed earlier that this red represents the base foundation. This base foundation is going to be 6 inches deep, and this is bolted to the base, and then you'd be pouring your concrete up to the floor level. There's a little shelf, and the concrete will go just over that ledge, so you'll end up with a nice neat flat floor with the concrete poured back up to the floor level, and it covers up to the steel exterior of this tornado shelter. Once everything is bolted together, we add these steel L brackets to the corners. They take up with the bolts that come from the roof all the way through the cord. They get bolted through the bracket. Then these bolts from this vertical leg come through, and they're going to pick up on the steel on the outside here. So it's an additional bracing in the corners to make sure that we've got extra strength in the corners. All the doors on these shelters are going to be FEMA 320. This particular door came to us and it comes with extremely strong hinges. We beefed that up by adding our own bolt system and bolt these frames straight through the cord again. Everything that we're doing with these steel bolts is bolted through the actual vertical cord. And the door's no different. It gets bolted in all the way around, so there's no way that this door can come loose. On the inside, it's got these 4 deadbolt locking system that comes standard with the door, and then we're going to add an additional bar on the inside that slides in once you're inside the shelter, just to give it extra strength. On this gable end wall that's going to have the door on it, the door can be offset over here, or in this case it's in the center, but with this framework we need to beef it up. So this steel plate is continuous and it has 2 tubes inside this, and it's through bolted. So it has the steel plate bolted to this top cord that has an insert and an insert, and both of those are bolted through, and then it has a header beam above the door to give it extra strength above the door. So again, it's extremely strong. Everything's bolted from the steel sheathing all the way through the brackets. Okay. With the gable end walls, they're a little bit different depending on where you've got the position of the door. If the door is to one side, then we can repeat the same width bays that you've got on the side, but this one is in the center, so these are special purlins. These are the only purlins that are different on this whole unit. So also with the gable end, there's a little bit more drilling. These are through bolted as well as T-bolted into the leg, so that we can put the steel outside sheathing on. You'll see these bolts ready to receive the steel that's going to go on the outside. Alright, so we're finished with putting the steel on. It's completely bolted on and through bolted through the actual verticals on every face. This is the gable end showing the door. The door in this position, like we said before, is in the center, and you can alter this and go either to one side or the other depending on what room you put it in. As we talked about earlier, these doors are Securall storm safe doors, so they're all FEMA rated. They're going to be at ground level, and these doors can be anywhere between 42 inches wide and 84 inches tall, so we can specially make them to your requirement. Being that wide, it makes it very easy for wheelchair access, or any mobile type device for handicapped and disabled access. So you can get into these things quickly no matter what you've got. The whole concept of this system is that it goes inside your house. You can quickly gain access to it. It can be in the garage if that's easier for you. But these systems, as we've seen, are quick to install. They're extremely solid, and everything is bolted through the systems. Once we've got this far, we would then be pouring the foundation pour. So you would be at this height, and you're going to pour your concrete up to the underside of this steel. And that's going to be level with your existing floor. If you remember from earlier, this is bolted down to a 6-inch base foundation, and so the red represents that foundation that we dug out previous, and then we'd be pouring the concrete once we're in this set state up to the level of the steel. And then on the inside, you're going to be up to the level of your floor level. We'll float the concrete, and then you can floor it how you want to. Inside, you see it's all shelled out, the steel's completely bolted in, and you're just left with a framework that's a skeleton framework. And the concept with this is, once we're in this position, you've got the shelter set up, you can finish this out how you want to. You can drywall it out and make it pretty. You can sort of build it out and make shelving. You can do whatever you like to make yourself comfortable, or actually be able to use this room as a fully functional room. We can run wiring into it if needs be and that sort of thing. So it doesn't have to be a wasted room. It can be a functional room, but it's a room that you can quickly get into, and if a tornado comes along and tears the house down, this will still remain. So depending on what room you put it in, they can be as small as you need or as large as you need. We can put them into schools, we can put them into, there's not really any restriction on how big we go with them. The concept is really for people in their homes just to be able to stay in the home with a tornado. There's short notice with a tornado, obviously, and this is something you can get into and you can be safe.